Hi, in this video, I'm going to introduce you to the AC method for solving trinomials of the form ax squared plus bx plus c. Now, it is called the AC method because we multiply this a and the c to get a number, but let me just show you using an actual example here. So you multiply 3 times 12 to get a number, and you have to find two numbers that's going to multiply to this number and also add to b, add to 20 here. So just by me saying that, 3 and 12 could be the right two numbers. So let's try adding them. 3 plus 12 results in 15, but that's not 20. So these two numbers are no good, but we can try to divide this number by other numbers. By 2 divides evenly, and the quotient is 18. Oh look, 2 plus 18 results in 20. So we found our two numbers. And then once we found the two numbers, we rewrite the original expression using those two numbers like this. So we actually change this middle term here. We rewrite it like this, and we actually leave this first term and the last term alone. They never change. So now what we do is we have to have the two brackets, right? That's what factoring means. And we first want to take care of the 3x squared. So we put 3x here and then x, that's going to result in this. What about this other number here? Now that's where this rewritten expression comes in handy, is that you can see that 3 will divide evenly 18 by 6. 3x times 6 is 18x. So we found our three terms. Just one term is remaining. And to find that, we can either do it two ways. We can find a number that's going to result in the constant term when multiplied by this term, 6. So we find that the number is 2. And look what happened. 2 times x is this also. So that's the other way of solving this, is you can find a number that when multiplied by this guy here is going to result in this term, the other x term. So let's work on another problem to get more familiar. So this one also, you multiply 14 by negative 12, so sign matters. And you get negative 168. Now, remember what I said before, that these two numbers could be the right two numbers that we're looking for. Let's try adding them. 14 plus negative 12 will result in plus 2. So we already found our answer, or two numbers that we're looking for, and we can once again rewrite this trinomial using those two numbers that we found, modifying the middle term. And then we first try to take care of the k squared. Let's try just 14k and then k. Now we have to see whether this 14, the coefficient, will divide evenly, either this one or this one. And it does, so we're good. So we can do that check at this stage. And we find this other number, plus 1 will work because 14k times 1 will result in one of these two terms, namely 14k. So we just have one term remaining. So we can do that, like I said, either of two ways. One number, when multiplied by 1, will result in negative 12. That's negative 12. And also, negative 12 times k is negative 12, the other term, the other k term. So we could have done it that way. But I think doing it by the constant term easier. Let's work on another problem. So 6p squared negative 35 p plus 50. So we can notice that since this constant term has a positive sign, that like the two numbers that we are finding may have plus or negative minus minus. Like the sign of the two numbers that we're going to find will have to be the same, actually, from just looking at this sign of the constant term. But anyway, we do the similar thing. 6 times 50 is 300. Now 6 plus 50 is never going to result in a negative number, so these two numbers are out. So we try some number. 300 divided by 2, 150. Now it's gonna not result in anything like 35, so and neither is going to 3. So we keep trying. I'm using my calculator, but we keep trying until we get to 15 and 20. Now these two numbers look more plausible because they're similar magnitude as 35. But notice the sign again. We have to add these two to get to negative 35. But we can do that if we simply assign negative signs, because these two guys add up to negative 35, while also this multiplied by this results in positive 300, like I mentioned before here. So we rewrite the trinomial in the same way, and it does not matter like which one I write first. It could be negative 15p or negative 20p. The way I'm doing it, it doesn't matter. And just a reminder that this first term and the constant term will not change when you do the rewrite. So you can look at the middle term as being this. So now we could try 6p, but notice that 6 does not divide evenly 15, nor does it 20. But like I said before, this coefficient number has to divide evenly either of these two numbers. So the factors of 6 are like 1 times 6 and 2 times 3. So if we try, say, 3, then we can see that 3 divides evenly 15. So that's good. We can use 3p. And because we use 3p, this will have to be 2p to result in 6p squared. And this other term will be negative 5 to result in negative 15p. And we just have one other term here remaining. Let's do it the other way. So we got the negative 15p from negative 5. And we can get the negative 20p now from negative 10, because negative 10 times 2p is negative 20p. And also negative 10 times negative 5 is plus 50. So it checks out. So this is our factor trinomial. So thanks for watching this video. I hope that helped, and I'll see you in the next one.